A very good morning, students. Let's understand the solution of the difference equation. Earlier, I have uploaded a video using the same concept, but let's understand it one more time. So, general procedure for solving a difference equation is apply. I hope you are clear with the Z transform as of now. Apply Z transform on both the sides of the given difference equation. Expand the formula. Take Z transform as one side of the equation and then the remaining other side. In the last, you're going to take inverse Z transform. That the answer will be in the form of x of n, and apply the partial fraction method or any other method if you know to find out the inverse Z transform. This is the generic method. Now, what type of questions you can face? Your question can either be in the form of time advancing or on time delay, as we have studied in the module 1. So if I am talking about time advancing, you can get either the signal in form of n plus 1, n plus 2, n plus 3 or any other form. And if I am talking about the time delay, you will be getting the signal in the form of, so the sheet is the form of combination of both time delay and time advancing. So the question can be either in the form of k plus 3, k minus 1, k plus 2, k minus 2, k plus 1, k minus 3, any one of this equation. So we know that simple Z transform of x of k is x of z. So notice the difference between these two. Whenever it is k plus 3, the equation is becoming z cube. When it is k plus 2, it is becoming z square. When it is k plus 1, it is becoming zxz. So that is z to the power 1, z cube, z square, z1, and then the corresponding equation, that is z cube, z, and this will be the initial condition that you have mentioned. So the different solution of the difference equation is nothing but the combination of the initial state and the current state. Okay, and this will be the z cube, z square, z to the power 1. So if it is k plus 2, z square, initial condition of z square, z to the power 1. K plus 1, z to the power 1, initial condition of z to the power 1. And if it is k minus 1, only z to the power minus 1 will be there. K minus 2, z to the power minus 2. K minus 3, z to the power minus 3. Let's understand this concept one more time. So as I have told you that your question can be in the two forms, either in form of time delay or in the form of time advancing. So if this will be the generic formula you will be using every time. So z of n minus k is nothing but z to the power minus k. It's z transform. X of z plus summation n equal to 1 to k x of minus n z to the power n. This is z to the power n. Okay, so for example, taking the value of k as unity, that is 1, then formula becomes x of n minus 1, z to the power minus 1, x of z, x of minus 1, z to the power 1, because it was z to the power n. So n also, you have seen that I have taken 1 because minus n I have replaced by minus 1 and z to the power n I have replaced by z to the power 1. Solving the formula further, x of n minus 1 becomes z to the power minus 1 x of z plus this z inverse and this z to the power 1 cancels each other, only x of minus 1 remains. So hence you must have noticed that whenever we are going to solve x of n minus 1 or x minus 2 or n minus 3 or n minus k terms, the formula becomes z to the power minus k x of z plus the further extension. Let's again compare the time delay and time advancing. So you have to understand the question from this point of view. Either it will be in the form of time delay or it will be in the form of time advancing. So x of n minus 1 will be z to the power minus 1, x of minus 1. We have derived the similar thing above. X of minus 2 will be z to the power minus 2, z to the power minus 1, and then the z to the power 0. X of n minus 3 will be z of minus 3, z of minus 2, z of minus 1, and dot z to the power 0. x of minus 4 will be z to the power minus 4, z to the power minus 3, z to the power minus 2, z to the power minus 1 and z to the power 0. So every time you are getting a question, convert it into this extension. The equation can also be in the form of n plus 1, n plus 2, n plus 3 and n plus 4. Here the initial condition, if you are advancing the signal, you must know the previous or initial condition also. That means you need to see z to the power plus 1 and the previous condition, that is z to the power 1 x of 0. n plus 2 z square, its initial condition. n plus 3 z cube, its initial condition. n plus 4 z4, its initial condition, and the corresponding states. So these are called as initial condition and these are called the state equations. So what is going to happen? Your difference equation will be combination of initial condition and the state equation. So whenever you are going to add the initial condition and the state response, the complete solution of the difference equation will be obtained. I am again repeating it, the difference equation is the combination of initial state and the initial condition and the state equation. For example, you might get let's take an example for solving a difference equation. You will get a question in this form, 0.5 y to the power n minus 1 plus x of n. So when input is unit step and initial conditions are also given to you, that is y of minus 1 and y of minus 1 is equal to, in first case it's 0, in the second case just 1 by 3. So first step, what you going to do, take this y of n minus 1 to the left side and x of n to the right side. That means y of n is your response, x of n is your input. You need to find the response when the initial conditions are there. The response is already given to you in the question. You just have to put these initial conditions. Before putting the initial conditions, you have to bring the given response into this or this form depending upon in which your question is given. So take this left side, bring response to the one side and input to the one side. The question says the input is unit step. When input is unit step, the question is saying when input is unit step, put equate x of n equal to u of n, this whole equation on left side, and x of n replaced by u of n. Now taking the z transform on both the sides. So y of n gets converted into y of z. 0.5 y of n minus 1 gets converted into 0.5 z inverse y of z plus summation n is equal to 1 to 1 y of minus 1 z to the power 1. This is the same formula we have used over here. It's just that x is replaced by y. The formula remains same irrespective of we are using for the state equation, that is input, or we are using for the y of n, that is output. So is equal to u of n, z transform of u of n is z upon z minus 1. So I have used this formula, I have done the formula over here just for your explanation. So taking this y of z, whole formula as it is, and z upon z minus 1. Opening the summation sign, this is only for one case, that is input, what, unit step. So we have taken n is equal to 1. So y of minus 1 z to the power 1. Now this is the first step for the solution of the question. Now talking about the initial conditions. First A part says when initial condition is 0, B part says when initial condition is 1 by 3. So using this equation, putting it to the left side, y of z in common, we must have used these steps in solving the inverse z transform also. Then z upon z minus 1, taking this to the denominator of the right hand side, z upon z minus 1, taking this z over here, yz upon z, finding the value by using the partial fraction expansion method, and obtaining the final y of z, taking again this z in the numerator on the right hand side, and finally calculating the inverse z transform. So this is the response when your input is unit step and your initial condition is 0. Similarly, you have to find the B part when input is unit step, which is z transform is z upon z minus 1, and initial condition is 1 by 3. Now replace this y of minus 1 with 1 by 3. Following the same steps, take yz in common, bringing all the z values to the right hand side, the denominator of z in the denominator of left hand side to the numerator using the partial fraction expansion method, and finally obtaining the inverse z transform. You can get another type of example in this module, that is find out the magnitude and phase response. So the question will be given to you in the form of h of n. It can be x of n, y of n, anything will be given to you. Just understand whether you are able to find the z transform of this particular response or not. So taking the z transform on both the sides and then replacing. So the question is saying find out the frequency response. Then replace z by e to the power j omega. So whatever z transform you have obtained, equate that z by e to the power j omega. So you will get this equation, put the formula of 2 cos theta. So this will be your final h omega. So your h of z is converted into h of omega, that is z transform is converted into frequency response. Plot the magnitude and phase of this particular response. So you just have to take some random values of the omega and put these values of omega on the x-axis, and on y-axis you are going to obtain the magnitude and the phase. Try this, try many more examples on this particular concept. So as I have told you, you need to get the two type of questions in this module. One is the solution of the difference equation. One is the solution of the difference equation, this type, and other is the find the magnitude and phase plot. Try to solve more examples on this particular concept. Thank you very much.